Welcome to the Embedded Design Flow video for SmartFusion. SmartFusion Intelligent Mixed-Signal FPGAs are the only devices that integrate an FPGA, an ARM Cortex-M3 processor, and programmable analog, giving us a design flow that includes FPGA, embedded, and analog design. This video covers embedded design using Soft Console and will show you how to set up a Soft Console workspace, configure your SmartFusion device, generate a sample project, program the configuration to the device, and then run your program. Let's start by opening Actel Soft Console. We select a workspace, and then this Eclipse-based IDE will open. First of all, we're going to set up the MSS configurator as an external tool. So we double-click on Program, and then type in MSS configurator as the name. And then we use Browse File System to go select the Smart Design executable from the Libero installation. Once that's in place, we add an argument that tells it it's being run by Soft Console. And then we can go ahead and run the MSS configurator. This allows us to configure our microcontroller subsystem of the SmartFusion device. We select which device it is we're using, and then it will generate a full block diagram of the microcontroller subsystem. First of all, we disable components that we don't want to use within the SmartFusion device. So for this design, we're only going to use UART0 to set up a hyperterminal to talk to the SmartFusion device. We should always check our clock management is set up correctly, so we're using the on-chip RC oscillator, creating 100 MHz into the device. When that's complete, we can generate our microcontroller subsystem. This takes just a few seconds. And then once that's done, we can go look at the I/O editor, which will actually show us the I/Os that we now have configured on the part. And then we can also go to the firmware tab, which allows us to generate a sample project, in this case a pulled UART specifically for the Soft Console design environment. We have to go select the correct workspace where we would like it to be generated. And then we want to actually show the generation report so we can see all of the files in hierarchy that are created during this step. The next thing that we have to go do is we actually have to program the configuration into the device. So again, we need another external tool here, the FlashPro Programmer. So this is software for programming Flash-based devices. We browse the file system to go select the FlashPro executable, again from your Libero installation. And then we can just hit Apply and Run. In the FlashPro software environment, we set up a project first. We have the correct project location, so we just give it a project name. And then once that's set up, we actually have to go create a programming file. So when we configured the device, it created an EFC file, which defines the configuration of the microcontroller subsystem, and we take that EFC file and we tell the device we want to program it into the embedded flash memory. So we go find the EFC file using the import option, and that's stored under the component work MyMSS. This is where it's generated. So we take our EFC file and we use that to generate a PDB file, which is a programming file. Now I have my board connected to the programmer right now, so we're going to go ahead and click Program, and that will program just the MVM portion of the device. We're not using any FPGA in this design example. Once that's completed, we can go exit FlashPro and go to the next step. So back in Soft Console, we're now going to import that sample project that was generated by the MSS configurator. So as you remember, we generated it under the Soft Console workspace directory, so we're going to select that directory, make sure the files are there, and then we press OK. This will import it into the Project Explorer on the left-hand side of the Soft Console screen. You can expand that file and look at all the files that were generated as part of that sample project we created. We click on Main and build the project first. That will build pretty quickly, it's a small project. And then we want to set up our debug environment so that we can actually go run the design on the device. For this example, we're just going to run it from the on-chip RAM that is on the SmartFusion device. So we go ahead and we launch the debug window. And this programs the code down to the device and gets it ready to run. But first of all, since we're going to talk to a hyperterminal, we actually have to go set up that hyperterminal on the computer. So let's do that. I know that my board is connected to COM4, so we'll select that as the input for the hyperterminal. And we're going to set up from the code, it said to set up the bits per second or baud rate as 57600, and we set flow control to be off, and that sets up our hyperterminal settings. And then we want to adjust the two windows so we can actually see the soft console and the hyperterminal on the screen at the same time. So now if we go to run the actual design example, it will export SmartFusion says hello from the SmartFusion device to the hyperterminal. This video has demonstrated the embedded design flow. You can use the links below to view the FPGA design flow or to get your own software and SmartFusion evaluation kit to begin your first SmartFusion design. Thank you for viewing the SmartFusion embedded design flow video.